let's talk about unit of current. So, people who are not very clear with what is a unit per se. So, this is for you guys. Unit of time is second. That is, we use second to talk about time. If I tell 1 second, you know that we are talking about time. If I tell 1 meter, right, we're talking about length. So, the unit of current in the same way is ampere, or you can write it as capital A. Either ways, it is the same. So this has to be capital letter A, if not a small letter a and MPERE. Like Newton, it's similar to Newton, wherein we write capital letter N, right? 10 Newton is 10 N, 10 capital A, 10 ampere. The reason we use capital letter and small letter in different units is whenever you see a capital letter, single capital letter, it is to do with a person's name. This unit is named dedicated to a person, their contribution in that particular field. So a person, a scientist named Ampere, has a lot of contribution to the understanding of current, right? So that's why we people named it as Ampere, and to indicate that it's a person name, it's out of respect, we write capital A. It's something like that, you know. So remember, it is capital A that you need to remember. If you want to write it as a whole, right, meter, second, right, write it this way. In the same way, you write it as AMPERE, ampere. The very next thing in physics that you do is you define a single 1 ampere, like 1 kg, 1 meter. We need to define 1 ampere. For that, we need to start with the formula. What is the formula of current? Current is equal to what? If you're not able to remember, quit. Q is equal to I into T. So I is equal to Q by T, right? Where Q is charges, a single charge charges, and T is time. So rate of flow of charges with respect to time is your current. Okay. Now the next thing is we need to define 1 ampere. For that we need to know what is the unit of SI unit of Q, that is the charges, and what is the SI unit of time. The SI unit of charges is coulomb, denoted by capital C. Again, it is named after a person, so that's why the letter is capital, and time is second. Okay, so we need to define 1 ampere over here. See, I'll ask you a very commonsensical question. I want 1 on the left hand side, and I have two numbers getting divided on the right hand side. What can these numbers be? They can be 4 by 4, is it not? 5 by 5, 6 by 6, 100 by 100, 121 by 121. Because when you divide those two, I'll get 1 over here. See, remember, I want 1 ampere, right? And on the right hand side, we have two quantities dividing. What is the best possible number? 1 and 1. So basically, I have 1 ampere being equal to 1 coulomb of charge divided by 1 second. But this is not the final answer. We need to define it, put it in words. So how do you do that? It's simple. Electrical current. Okay, let me not write V. Yeah, I have the definition over there. So I'll put it in words here. The current through a cross section of wire is said to be 1 ampere if 1 coulomb of charge flows in 1 second. Right? See here the same word, cross section of our conductor. Same thing here you can use. So we said to have we said to have current through a cross section of wire is said to be equal to 1 ampere if 1 coulomb of charge flows through 1 second. We said to have 1 ampere if 1 coulomb of charge flows through 1 second through a conductor, or you can put it in many ways, right? I think I confused you guys. Let me not do that Let me show you the actual definition. Better to do that, right? So electrical current through a conductor, simple way to start, is equal to, is said to be 1 ampere if we're talking about putting a condition, 1 coulomb of charge, right, flows through a cross section of the conductor in 1 second. Okay, so that's a quite simple definition, is it not? So let me repeat the entire thing. We started with understanding charges. Charge is a fundamental part of what we understand in the universe. It's one of the most fundamental things, like gravity or mass, and not gravity, sorry, mass and things like that. It's property of matter, right? So then we started understanding that, okay, when it starts flowing around, we have current, and we call it as electrical current because electric word has to do with any phenomena associated with charge. Then we define current, that current is nothing but amount of charge flowing through a cross section of a conductor in 1 second or unit time, right? And then we looked into the SI unit of current. When I tell unit of current, that is SI unit of current, that is ampere, named after a person, so we'll write it as capital A. The very next thing that any physics topic will ask you to is define 1 ampere. What is 1 ampere? How much is 1 ampere? Very simple. Write the formula. Know the units of the right hand side as well. So we have 1 ampere of current flowing through, said to have 1 ampere of current passing through a wire which has 1 coulomb of charge flowing through in 1 second. Right? If you know the form, the formula, right, and the units, writing the definition is not that big deal. Of course, the sentence framing will be altogether weird, right? But of course, if you make sense out of it, you won't be losing marks. Okay? You can't miss the words 1 ampere, 1 coulomb of charge flowing in 1 second. If you don't miss these keywords, you're pretty much done with the definition. Right? So now you can pause and have a look at the definition. Let me start from here.